Yeah, good morning everyone. So in the last videos we have seen some demo classes like introduction and some sample programs and even the linked list representation. So how we can represent that linked list with the help of a diagrammatic explanation I have given very clearly for you. Now from today I'm going to start the actual content. Of course already we started, but I'm going to repeat one by one. Okay, so first chapter. Okay, the first chapter what we have here is introduction to DSA. Okay, introduction to DSA. Sir, if we are talking about the first algorithm, so what is mean by algorithm? Already I provided definition, right? So step by step process to solve a problem is called as an algorithm. Generally, we won't prefer this algorithm for small problems because we know very well about the programming languages. That's why whenever we are seeing any problem, directly we will go for implementation. Suppose consider if the problem size is very big, then we will take maximum time to analyze the algorithm. I mean, to analyze the problem statement or what is that a problem statement, how we can able to solve that problem that we have to analyze, right? So for that, we need to go for algorithm. First of all, we have to prepare algorithm. Okay, first of all, we have to prepare the algorithm. Once if you are preparing the algorithm, then solution will become very easy for us. Okay, solution will become very easy for us. So for that purpose, we have to design an algorithm. I think already I explained a step-by-step process to solve a problem is called as an algorithm. So we are going to write a step-by-step process. Example also I have given. Suppose if you want to calculate addition of two numbers, what steps we are going to write? What is the first step for calculating addition of two numbers? We have to read the value of A from the user. And the second step, we have to read the value of B from the user. What is the third step? We have to compute the value of C is equal to A plus B. What is the fourth step? We have to print the value of C on the console or screen, or we have to return the value. Of course, since the problem statement is very simple, a four-line steps we have written. If the problem statement is very big, then we have to write n number of steps. Then even we discussed about the flowchart. If we represent the same algorithm in the diagrammatic manner, then it is called as a flowchart. We can call a flowchart as diagrammatic representation of an algorithm. If you have an algorithm, we are going to write a flowchart for that algorithm. And I think in the beginning demo sessions, I explained very clearly about how to draw the flowchart. Of course, it is not required here. So it is not required here because we are not going in detail. Then coming to the implementation, A is equal to input of enter A value, B is equal to input of enter B value, C is equal to A plus B. So I accepted the value of A and B from the user. Then we are calculating addition by using the formula like C is equal to A plus B. And printf, in a formatted string, I am printing A value followed by B value and C value. So A and B are nothing but inputs and C is nothing but output. Like this we are going to print. Sir, already these things we covered very clearly. Now I want to talk about advantages of algorithms. Sir, what advantages we have in the algorithms? Very simple, sir. So first one, here the problem will be simplified, right? If we are taking any big problem, we are going to simplify the problem. Okay, that is the advantage of algorithm. So that any problem we can able to find the solution. Next, sir, easy to understand the problem statement. Easy to understand the problem statement once if you devise an algorithm for that. Because, sir, if the problem is very big, if the problem is very big, okay, so then dividing this problem into individual steps, step by step, if you are analyzing, for example, consider matrix multiplication is there. So we know very well n number of steps will be there in this. Sir, first I want to read the matrix A, then I want to read the matrix B, then I want to initialize the matrix C, then I need to calculate the value of C, then we have to print the value of C. Like, this is one step, this is one step, this is one step, this is one step, this is one step. Sir, I'm getting the proper result, okay, but at the time of printing, I'm getting all these matrix elements line by line. There is a problem in print statement. Sir, the multiplication is perfect, okay, I mean, the input is correct, output is also somewhat correct, but in the calculation, sir, one, all these 3 by 3 matrix if you take, so here I am getting problem, means what, at the time of calculation here is the problem. So in this particular row and column calculation there is an issue. That means we have to open only this module and we have to verify. That's why, so the problem, entire problem, if you write an algorithm, sir, it will be easy to understand, it will be easy to understand. Next, and after that, easy to implement also, easy to implement, step by step, module by module, we can able to implement. First we will write the code for reading A matrix, then we will write the code for reading B matrix, and we will check whether it is working properly or not. If we are having any issue there, there itself we can able to debug the code, okay, before moving to the next step. So that means easily we can able to implement the program. So next, and after that, next and after that, we will get a format, sir, we will get a format, we will get a format, or we will get a template, or we will get a pattern, okay, for solving the problem, right? So if I am unable to solve the problem, once if you write the algorithm, then you are going to get some format, how we can able to solve that problem. We are going to get a specialized format. That is nothing but what is the advantages of algorithm. I request everyone to please confirm, so what are the advantages of algorithms? Is it clear for you people?
Yes, yes,
Yes, requesting everyone to please respond.
yes, yes, yes.
Try to use chat window also for communication purpose. Right, good. Sir, now, so the next concept, theory part only. The next one is nothing but, do you know, algorithm is having some properties, sir. So directly you can't write algorithm, sir. We have some properties. While writing the algorithm, you have to check whether your algorithm is satisfying these properties or not. Sir, what properties are there? Every algorithm, okay, every algorithm should take should take either zero or more inputs. Compulsory, every algorithm should take either zero inputs or more inputs. Zero input means what? There are some algorithms which should not take any input. For example, consider I want to print a welcome message. Okay, so in such cases, is it required to take any input from the user? No. Such a type of algorithms are not going to take any inputs. So, but it is considered as a zero inputs. Every algorithm should take either zero or more inputs. So next, and after that, very very important second point. So one or every algorithm should produce either one or more outputs. Every algorithm should produce either zero, sorry, one or more inputs. So at least one input, at least one output should be there. So because we are writing algorithm for solving a particular problem, so if you are solving a problem, definitely solution will be there, right? That's why, so every algorithm should take zero or more inputs, but at least one output should be produced by the algorithm. Compulsory, my algorithm has to produce at least one output. Compulsory, sir. That is mandatory. Okay. Next and after that. So our algorithm should be deterministic. Sir, what is mean by this deterministic? We have to get the same output for the same input if we run again and again. So because, sir, I am writing a program for calculating addition of two numbers. First time I am giving 1 and 1, my output is a 2. Sir, after 1 year, okay, after 1 year, I'm giving the same input 1 and 1. So I'm getting output like 3. So it is not a deterministic. Okay, my algorithm is not correct. So an algorithm is said to be deterministic. It has to produce same input. If you supply the same input after a long time also, that algorithm has to produce correct output for that. This is nothing but what we have. This is nothing but what we have, sir. Okay. Right. So next one, what we have, every algorithm should be correct. Whenever we are writing the algorithm, so you have to keep it in mind that for what purpose you are writing, so that algorithm should have, you have to write in a correct manner. You should not do any mistakes. And compulsory, so your algorithm should terminate at a finite number of steps. Okay, your algorithm should terminate at finite number of steps. Means I can able to say base condition. Compulsory it has to stop, sir. Okay. So there are some algorithms are there which are going to keep on running. So we should not prefer such a type of algorithms because efficiency is not going to come. At the same time, the program is never terminated means it is not correct. So whenever we are writing a program, it should terminate at certain point. Okay, maybe it is 100 number of times or 1000 number of times, that doesn't matter, but compulsory it has to terminate. Okay. So next and after that, your program should be efficient. Okay, with respect to logic, sir. So your logic should be clear. Your logic should be clear. So you have to write a clear logic, sir. Okay. So these are nothing but some of the properties of algorithm. So we have to follow these properties. We have to follow these properties while writing an algorithm. What is the first property? Every algorithm should take either zero or more inputs. Okay. And at least one output should be produced, and your algorithm should be deterministic. Okay, that means it has to produce same output for same input if we run again and again. And the algorithm should be correct, and it should terminate at a finite number of steps. That means we have to provide a proper base condition, and your program is efficient. Okay, your program is efficient. That means logic should be very clear. So this is nothing but what are the properties of algorithms that we have. Okay, I think these properties are very clear for you people, right? Can you please confirm any doubts up to this?
Sir, the first point, sir, every algorithm should take zero or more inputs. Means here zero means a value zero or doesn't have any significance for that one, sir.
No, no, wait 1 second. I will clarify your doubt. Yeah, can you please ask the doubt again?
The first point, sir, should take 0 or more inputs.
Mm-hmm.
So when if you are considering the value 0, it
Mm.
doesn't build any of the steps from starting step 2, no, so it doesn't produce any output.
No, no, no. See, something like you can consider it is a program. It is something like a program, sir. Is every program is going to take input means no. Some programs directly we are going to run without input also, right? That's what we are telling. So, for example, consider I am telling I need to find factorial of a 5. For that program, do we require to supply any input? No, because I have given the input statically, right?
Yeah.
So, in such a cases, there is no input. Okay, but coming to the output, compulsory, why we are writing the program? To execute and to see what is happening. So in such a cases, at least one output should be there. Okay, getting the point?
Got it, got it.
Hmm. Yeah, so all my previous classes videos are available. Don't worry, I will share at the end of the class. Right. So the next one, complexity of algorithms. Complexity of algorithms. Sir, here you can able to see already I explained this. Just matter of 1 or 2 minutes, I will demonstrate. What is mean by complexity? Complexity of an algorithm is the amount of time and space. The complexity of an algorithm is the amount of time and space required to complete its execution. The amount of time and space required to complete its execution. So if you take any algorithm, how much time it is going to take to execute, or how much space it is required to execute, that will be calculated by using this, that will be measured with the help of complexity, the amount of time and space required to complete. Sir, I want to travel from city A to city B. How much time I am taking? Okay, suppose if I don't have any work, simply I am going to take any path to reach the destination. Suppose consider I have a commitment with respect to time I need to reach. That means what? So there will be multiple options, multiple paths, multiple routes will be there. I will try to find out the shortest route so that I have to reach the destination within a short period. So means what? I am talking with respect to time, how much time it is going to take to reach the destination. So that will be divided by using this time complexity. So for every algorithm we have to calculate a time complexity, which is represented by using t of n. And for every algorithm we will calculate a space complexity, which is represented by using s of n. So time complexity is nothing but the amount of time taken by the algorithm. Space complexity is nothing but the amount of space taken by an algorithm. So how much space it is going to take, how much time it is going to take, is represented by time complexity. So what is the units to measure these things? In the sense, seconds, milliseconds, nanoseconds, like that we can represent the time. And coming to the space, bytes, bits, kilobytes, megabytes, like that we can represent. Okay, anyway, for representing this, there is some mathematical representation is there. Like what we have here is asymptotic notations. Asymptotic notations, I'm not going in detail about these asymptotic notations as of now. Okay, we will discuss later. We will discuss later. Otherwise, just I will give outline. 1 second. Right. So just let me write at least a definition. So what is mean by asymptotic analysis? Sir, here calculating. Okay, calculating running time and space, running time and space of any algorithm, running space and time of any algorithm, running time and space of any algorithm in mathematical representation. Okay, in mathematical units, in mathematical units. Okay, mathematical units of computation. Okay, computation. So is known as asymptotic notations. Okay, asymptotic notations or asymptotic analysis. Sir, there are three major notations are there. By using these three notations only, we are going to measure these time and space complexities. Sir, the first one is nothing but big O notation. Big O notation. Sir, this big O notation, okay, big O notation, actually we are representing like a capital O. The second one is nothing but omega notation. Omega notation. Actually, there is mathematical some special symbol is there, but it is not possible to draw by using keyboard. That's why I'm going to take W. W represent omega notation. Then, so one more notation is there called theta notation. Theta notation. It is also not possible to write. That's why I'm taking 0, 0. So how many representations are there? Big O representation. You have to take capital O of that complexity and omega of this complexity. Actually, this omega is represented in this state. Then theta, you know mathematical components. So by using these three notations, we are going to represent so the complexity of algorithm, whether it is a time or space, we are going to use these three ways to represent the complexity. Okay, so for this, a mathematical theory is there, but as of now, I am not going to cover that. We will see at the end of chapter 1. Okay, I think what is mean by asymptotic notations and what is mean by complexity, how you can able to calculate complexity of an algorithm. I think these concepts are very clear for you people, right? Theoretically, do you have any doubts, friends, up to this? Any doubts up to this? Please confirm.
Yes. Yes.
Right. So next and after that, sir, here the next one, complexity. Okay, complexity
Hello.
analysis. Complexity analysis of an algorithm. How we are going to measure this complexity? There are some cases are there. By using those cases, we are going to measure the complexity. What is the first case is nothing but worst case complexity. Okay, worst case complexity. So what is mean by worst case complexity? Sir, here maximum steps, otherwise I can write maximum steps required by an algorithm. If you take any algorithm, okay, if you take any algorithm, maximum how many steps is required is nothing but worst case complexity. Okay, sir, next and after that, best case complexity. Best case complexity. Okay, sir, best case means what? Minimum number of steps required, minimum number of steps required by an algorithm, and similarly, so we have average case complexity. Average case complexity also is there. So what is mean by average case complexity? So average steps required by an algorithm. Okay, generally, to measure this worst case, we are using big O. To measure this best case complexity, we are using omega. And to represent average case, we are going to use theta. This is the general representation what we are going to use. So but in maximum in our syllabus, we will concentrate, we will consider only worst case. Generally we will concentrate on worst case only, right? For example, consider, so I want to get salary by every month. So in between 1 and 10. So then I will ask that management people, are on the worst case when it will be credited? Means what? So final, beyond that there is nothing. So if they are telling by 10th, worst case by 10th means what? On or before 10th. That means maximum steps. Maximum steps. And if you take best case, if you take best case means what? minimum number of steps required. Minimum number of steps required. That means what? For example, if the salary got credit on the first, okay, on the first of month, then it is called as minimum case. Minimum number of steps. Average means what? Maybe fifth, something like that. Okay, one more example I will give you. For example, consider I have 100 students details are there. Okay, 100 student details are there. 100 students data is there. So someone asked, Are I want to search for the student called Raghu. I want to search for the student called Raghu. When I am starting searching, if we got the result at a very first location, suppose consider it is available at very first location, then this case is called as best case. After searching 50 records, in the 50th location I got the result, then it is considered as a average case. Okay, sir, after comparing 100 locations, at 100th location the data is available, then it is called as what? Worst case. Like, we can able to measure the complexity of an algorithm by using these three representations. I think you people got a very clear clarity about this. Can you please confirm any doubts up to this?
Yeah, please.
No, sir.
Sir, I have a doubt. So in triple one line, there is a minimum steps required by algorithm W or right? O
Hmm.
W
Yes,
O
sir.
0, right?
Yes,
So
sir.
what is the symbolic representation for that?
Just wait 1 minute. I will give that.
Yeah, that is omega, right?
Yeah, that is represented by using omega, sir. That is represented by using omega. Omega notation we are going to use for that. Okay. So, but here I can't type omega right from the keyboard. That's why just I'm giving W. Okay.
Yeah. Okay. Okay.
Right. Next, sir, do you know every algorithm is going to take some time? Okay, so that algorithm time we can measure by using this growth of functions. Already I covered some functions, so just I will recall these two functions. The first function I told, right, we will concentrate only on worst case. That's why I'm taking the representations only for big O. Constant time. An algorithm is going to take constant time, which can be represented by using big O of 1. 1 means constant time, unit time. Set example for such a type of algorithm. Assume I want to access nth element from the list. So assume I have 10 elements there in the list. I want to access fifth element. How we are going to write code for that? L of 5, right? Or A of 5. It is going to return fifth element. So how many instructions are required? Only one line code is sufficient. It is going to take unit time. It is going to take unit time, constant time. Suppose consider I want to perform push operation or pop operation into a stack. I want to perform insertion and deletion from a stack. Then it is going to take a big O of 1 unit time it will take. Suppose consider I want to insert an element into binary tree. Then first we have to compare with the root element, and is the element is less than root element means, so you have to insert in this left subtree. If it is greater than it, we have to insert in the right subtree. Again, we need to check like this. So it requires n number of steps. Okay. So it requires n number of steps. But in the case of stack and queue, comparisons, all these things are not there, right? Directly, if you are pushing an element, it will be added into the list directly. So that's why here we can perform push and pop operations is going to require constant time. Insert and delete operations also require constant time. Accessing the element from hash table. Okay. For example, if I want to access the element called 373. So if internally it is going to have some hash key. Let it be 3. So h of 3 in this location, which element is available, that is nothing but the value. Have you observed like this hash table data structure is there? There I will explain. Even in the hash table, the accessing of data is going to take a constant time. Okay, that's why when compared with other searching algorithms, hash table search is very efficient. Okay, so because it is going to take the constant time. Of course, it depends on the number of records also. That doesn't matter. We will see later. So this is nothing but about a constant time. So which algorithms will comes under constant time? Few of them I have listed there. Can you please confirm how this constant time is going to measure? Is it clear for you people?
Sir, I didn't understand. First of all, the growth of functions only, sir. What is it title, sir? Growth of function.
Generally how we are going to represent. For example, assume I have an algorithm is there. I need to calculate complexity of algorithm. Let us assume I want to calculate the time complexity. If I want to calculate a time complexity, how my algorithm is going to behave. Suppose assume I want to perform search operation. So I have 100 records are there. So if I want to search for 100 records, how the function is going to take, how the growth of the function, because if you have n number of values are there, I need to search for n times, right? So rapidly it is changing from 1 to n. That means a big O of n it will take. Sometimes I'm going to divide the entire list into half, and then in that half I want to search. That means n by 2. If it is taking double time, that means n square. So it is a growth of function means what? When we are supplying the input, how my algorithm is going to behave? Is it doubling the calculations, or is it dividing the calculations, or is it running in the same time? Like that it is going to calculate. That functions are there, right? Those are called as growth of functions. Along with input, how these functions are going to change. Got it?
Okay, got it, sir. Got it, sir. Yeah, thank you, sir.
Second. Sir, I request everyone to please respond. Clear up to this.
Yes. Yes.
Right.
Hello. Am I audible, sir?
Yeah, you are audible.
Yeah. Can you please explain it again? The growth of functions. Growth of functions.
That's what it's all, sir. So growth of a function means along with the input. Growth means what? How it is going to change, how it is going to increase, right? Along with input, how my algorithm is going to work. If you are giving 100 as a input, which function is suitable for that algorithm? So if the input is 1000, how that function is going to change? That is represented by growth of functions. Something like you have seen right in the graph theory somewhere. So here we are going to represent like this. I can say this is a function. When we are changing the inputs, so your algorithm output is also going to be changed, right? For example, consider here I want to perform searching operation. When input is very small, it take less time. When input is changing, it is keep on changing. This is called as growth of function. First function I covered big O of 1. Big O of 1 means what? So it is a constant time, need not be 1. Sometimes you can take 2 also, sometimes you can take 10 also. So a constant time we are taking means what? So for some algorithms, it require constant time. These are the examples. I want to access nth element from a list. Suppose consider I am accessing I want a fifth element in the list. So what will happen? If the list contain thousands of values, you are going to give the index L of 5 because fifth element. How much time it requires? Constant time, right? Constant time, only one step. Okay, suppose consider they want to print all the element, then what we have to do? We need to write a loop. Okay, first element we have to print, second element we have to print, third element we have to print. If n elements are there, what will happen? N times you have to run the loop, then it will become big O of n. But that is not the case here. We are accessing nth element. So if n is 10, only one step, L of 10. If n is 1 lakh also, L of 1 lakh. That's all. Only one line is sufficient. Okay. So these kind of algorithms will comes under constant time. Next, second one, sir, linear time. Linear time means what? An algorithm is going to be take linear time. That is, execution time is directly proportional to the input size. Okay, execution time is directly proportional to input size. Input size. So means what? Depending on the input size, the number of comparisons will be there. Best example, we have linear search is there. Linear search means what? We have to search for the data continuously. Okay, we have to search for the data continuously. Suppose consider I am going to give the input like for example, I have some elements are there like 1 2 3, so 4 5. This is my elements present in a list. Now I want to search for, okay, I want to search for the element called 6. Sir, first we have to take comparison with 1. 1 second. Right. So I'm going to search for the element called 6 within, I want to search for the element called 6 with the first element. Is this element is available? No, right? Then I'm going to search for the element 6 with the 2. So is the search is a successful? No. Sir, then we have to search for the element called 6 with 3. Is this element is available? No. Sir, can we search for fourth? Is the data is matched? No. Then I am going to search with 5. Is the data is available? No. So then the search is unsuccessful. Okay. But how many comparisons is required? Have you observed? First comparison, second, third, fourth, fifth. Because n is equal to 5, we need 5 comparisons. Worst case. Suppose consider I want to search for 3. Then what will happen? So here we are going to compare with this, search is unsuccessful. So here we are comparing, search is unsuccessful. Here we are comparing, search is successful. But it is going to take big O of n only. Sir, why? Because maximum number of steps we are required. Worst case we are calculating. But in this case, since the data is available within the half searching, so it will become what? Best case, I mean average case. Suppose if the data which you are searching is available at the very beginning, it is called as best case. If it is available at the last, it is called as a worst case. Sir, always we have to measure with respect to worst case. That's why linear search is going to take how much time? Big O of n. Similarly, I want to find maximum element. So how this algorithm is going to work? I will take first element as the maximum element. Then we are keep on comparing with the remaining elements. If anywhere match is found, okay, if anywhere match is found, then it is called as maximum element. I mean, then we are going to return that maximum element. But at worst case, how many comparisons are required? We need to compare till n, right? So this particular algorithm will comes under linear time, big O of n. Similarly, I want to find minimum element. It is also required big O of n. So do you know traversal of tree, like in order, pre-order, post-order? So suppose if tree is having 10 elements, every element we have to visit, right? How much time it will take? Big O of n, because n elements are there. Like that we are going to measure. Can you please confirm, is this linear time, how it is going to work? Is it clear? For all these things we will write algorithms, don't worry. With the programmatic explanation I will explain. Is it clear up to this?
Yes, sir. Very
Please
good.
confirm everyone.
Yes, sir.
Yes, sir.
Yes, yes.
Right.
Yes, sir.
Sir, next one, logarithmic time. Logarithmic time, that is nothing but big O of log n I am taking. Big O of log n, logarithmic time it is going to take. Sir, what is this logarithmic time? Very simple. An algorithm is said to be, an algorithm is said to run in logarithmic time. Logarithmic time. Okay. So if the execution time of an algorithm, okay, if an execution time of an algorithm is proportional, okay, is proportional to logarithmic of input size, logarithmic of input size, like that it is going to have. An algorithm is set to run in logarithmic time if the execution time of an algorithm is directly proportional to logarithmic of input size. Sir, I will give one example, then you people will get clarity. The best example for this algorithm is nothing but binary search. Sir, we have so many algorithms are there. I'm going to talk about only one algorithm, which is nothing but a binary search. Sir, what is this algorithm? For example, listen carefully. I have the elements from 1 to 100. These elements are already sorted in ascending order. Now I want to perform search operation. How this binary search is going to work? It will always compare the element which you want to search with middle elements. If you got the result, okay. If you are not getting the result, again you are going to check, is this element is less than this element or greater than this element? If it is less than, it will be available in the left part. If it is greater than, it will be available in the right part. Suppose consider it is available in the left part. Again we will divide this list into two. We will search in this part. Again the list is divided into two. Again we will search in this part. Like that we will have. That means if you have 100 elements are there, so next time comparison will be 50 elements. Next time we are going to compare only 25. Next time we are going to compare only 12. Next time we are going to compare with the 6th element. Next time we are going to compare with the 3rd element. Next time we are going to compare with 1st element. Sir, have you observed 1, 2, 3, 4, 5, 6, 7? Listen my words carefully. If you talk about linear search, it is going to take big O of n. Okay. So if n is equal to 100, how many comparisons are required? 100 comparisons. For binary search, it will take a big O of log n. Means what? So if number of elements is equal to 100, so it is going to take a log 100 base 2. Sir, do you know its value is nothing but 7. So in linear search, if you want to search for an element, how many comparisons are required? 100 comparisons are required. If you want to search in binary search, how many comparisons are required? 7 comparisons are required. I think you can able to see which algorithm is best, linear search or binary search. Binary search is best. When if the input size is very large, remember this point also. It is depending on input size only. If the input size is very large, then you have to use binary search. If you have two elements are there, I want to search for an element. Going for binary search is worst programming practice. Because if you have only two elements, big O of n means what? Big O of 2. Two comparisons are required. It is similar to almost equal to linear constant time. In such cases, we should not prefer the algorithm called binary search. So that depends on the input size. Remember carefully, majority of the students are having this doubt. Sir, for all the inputs, is it same? No. Depending on the input size, the time complexity is going to completely vary. Majority of the students are having confusion on their mind. If the input size is going to change, definitely complexity is also going to be reflected. Okay, sir, I think how this logarithmic time is going to work, how you can represent this, it is very clear for you, I think so. Any doubts, friends, up to this?
So is it only applicable to binary search or?
No. Like this, we have so many algorithms are there. If I'm giving those names here, you people are going to get confused. That's why I'm giving only one example.
Got
In
it.
future, we are going to discuss all these things.
Thank you.
Yes. Any doubts? Is it clear up to this? Yes, I request everyone to please confirm. Clear up to this?
Sir, how to calculate like binary search log n means in any mathematical way to like calculate the.
No, sir. No, sir. Generally, by seeing the algorithm itself, you can able to decide. Just I have given the clarity, right? Example, half of time. Generally, logarithmic time is going to take half of, sir.
Okay.
So like that, we are going to measure. If you want, I will take a loop and I will explain really is it going to take a log n time or not. But log n is the measurement. Okay. Anyone knows about merge sort? Can you please confirm? Divide and conquer. Have you heard about this terminology?
What, sir? Merge sort.
Divide and conquer.
Yes.
Merge sort.
Yes,
Yeah.
sir.
Divide and conquer. We are dividing.
Yeah. What these algorithms are going to do? It will divide the entire problem into half, right?
Yeah.
And again that half is divided into again half, right?
Yes.
Is it a logarithmic time or not?
Yes.
Yes, that's all. So the best sorting algorithms in the entire world is nothing but divide and conquer based sorting techniques like quick sort, merge sort. So selection sort is going to run two loops, big O of n square. Okay, like that. Two loops we are going to use. But quick sort, merge sort, these are going to take less time. That we will see practically how it is going to work. Don't worry at all. So with this, I'm going to stop today's session. Still some functions are there that we will discuss in the tomorrow's session. Okay. I think these demo related programs, all these things I will put at the beginning because already we started first chapter. So tomorrow we will talk about this growth of functions. Still some more functions are there. So that growth of functions with practical examples also we need to cover. That I will take care of tomorrow and the day after tomorrow classes. Most probably tomorrow will be the last demo class. From day after tomorrow, if you want to continue to this batch, you need to get registered for this course, sir. Okay, right. So thank you. We will meet for the continuation tomorrow.
Sir, good morning. I have a question. Shall I ask?
Yes.
So that course along means with the Python programming, right?
Yes, sir.
Suppose I'm not good in Python, will I continue means, for the concept or
No,
what
sir.
is your opinion?
Without Python knowledge, I think it is difficult for you to understand. At least if you know basics, then it will be good. Because now you are seeing only theory part. You can able to imagine and you can understand. Even when I'm taking algorithms also, like merge sort means if I'm explaining the merge sort, it will be very cool and good. But whenever I'm start typing the code, then sometimes you may not get that proper terminologies, because everything we are going to write in the Python program, right?
Okay.
So here you can see.
Hello?
1 second, sir. Please wait. I'm clarifying other student out. Please wait. Suppose here, if you see, we are going to have some factorial program will be there. I want to prepare an algorithm. I want to write the entire skeleton in the program, programmatic manner. So these statements you have to understand.
Correct. So basically, I'm experienced in terms of Java, right? I have more than a decade of experience in Java. So in that perspective, I wanted to learn the concept mainly.
At least you don't know Python, at least basics also.
Basics I know at some extent, but I can learn in a couple of weeks or so.
Yeah,
I'll
no
be
problem.
in a good
No
state.
problem. No problem. You can. Then no issues.
The only thing I was looking for concept mainly, so that because it's a DSA, so could
Yeah, no
apply.
problem. No problem. Then it is good. No problem. You can.
Okay, then. Thank you very much, sir.
Right, sir. Any other queries? Right, sir. So tomorrow we will meet for the continuation. I shared the previous class recorded videos in the chat window. You can check it. Okay.
Yeah, we have a session on the Sunday also. It's
No, sir. No, sir. Saturday and Sunday this week and next week also we don't have Saturday and Sunday classes.
okay.
Occasionally we will take Saturday and Sunday, that too lengthy sessions, some 2 hours like that, because there are some topics are there which we have to cover continuously for 1.5 hours like that. There, in such cases, we will plan for Saturday and Sunday, but regularly there won't be any session on Saturdays and Sundays. Sunday,
Okay.
definitely we don't have any sessions. Saturdays, occasionally I will take.
Okay. Okay, sir. Got
Right.
it.
Right.
So small query once more. So time wise, we will always be means stick to the same 8 to 9, right? Or some the time may change, or that will be
maximum
time
8 to 9 only, sir. 8 to 9 only. But we will see based on the registrations. If everyone is okay from 7 to 8 also, we will shift this batch from 7 to 8.
That's fine, sir. I mean that will be in the morning, means first half
Yeah, in the
only.
morning only. Morning only.
Yeah.
Morning only. Because majority of students are asking for 7 o'clock, 7 or 7:30 like that we will plan. But though I'm not giving any confirmation now. So it depends on the all students, because if any one student is not comfortable with the 7 o'clock or 7:30 like that, so then I can't change the timings, right? Because so he is registered for 8 o'clock. We have given commitment at 8 o'clock. If everyone is okay at 7, then I will shift. Same link only will be there.
Okay, cool. 7 to 10, and I do not have any concern. But in the evening,
no. I'm not going to shift this batch to any other morning extra timings or evening timings, night like that. It will be there at 8 o'clock only, maximum 8 o'clock. But once if all the students paid the fee, then I will ask everyone's opinion. If everyone is okay at 7 o'clock, then we are going to start at 7 o'clock or 7:30 like that. Because some students are asking at 7 o'clock. That's what. Beyond that, nothing.
Okay. And sorry, I couldn't attend the first 2 demos, so that's why I'm asking
I
one more
shared.
question.
Okay, no problem. So I shared the previous class links in the chat window, sir. You can refer that.
Yeah. So what is the tentative duration for the code? 2 months?
Sir, 2 to 3 months will be there, because first time we are dealing this in DurgaSoft. So tentatively it will take 2 to 3 months. In between, I will bind up.
Time is not a concern for me, just thought to ask.
Yeah, that's what.
Okay.
Yeah.
Okay, sir. That's all I have. Thank you very much.
Right, sir. Thank you. Thank you, guys. See you tomorrow.
Sir, if you miss any class, we get any backup record session?
Yeah, definitely, sir. Recording sessions will be available for you people. In the demo itself, I told, right? So you are going to get the videos also.
Okay.
So every session is going to be recorded. That videos you are going to get for 7 months access. 6 to 7 months access will be there for that. You can able to watch.
Okay. Thanks.
Good. Right, sir. Thank you. I'm going to close the session. See you tomorrow.